Hey everyone! We were tasked with creating or redesigning a product that will implement DFA methods. We also needed to use Creo and create an assembly design and CNC process for one of the selected parts in our product. We chose the pet grooming comb because it was easy to assemble and it was easy to make changes to make it fit our methods. In the outline, we'll be talking about the project description, the design assembly, parts design, the DFA analysis, manufacturing plan, and conclusion and results. The pet grooming comb created is intended to be functional for both pet owner and pet, is designed for ease of use in manufacturing, and more comfort for your pet. The pet grooming tool is widely used in many households. Many times they are cheap and they break if put under pressure, or if plastic that they use is left in an environment where it compromises the strength. On the original design, the manufacturing company began with cutting long pieces of brass bar stock into the receiving rail component. Then a computer-guided saw slices the stock into specified lengths. Next, a computer-controlled drill makes holes for the rivets and holes for the teeth in the receiving rail. Afterwards, the saw cuts extruded aluminum into specified lengths to create the handle. The material has already been preformed before entering the facility, and the comb has 2 rivet holes put in it to hold the receiving rail into the handle. Next, the receiving rail assembly is put into the handle, and the end caps are glued and hammered into each side of the handle. Our pet grooming tool will have an overall length of 6 inches. The wooden handle will have a diameter of 2.25 inches. The metal teeth will fit inside the receiving rail as the original, that is housed inside of our handle. The receiving rail is held in place by 2 screws instead of rivets on the outer ends connecting to the wooden handle. 2 end caps will cover the screws. We added a rubber composite material to the teeth on the bottom to increase comfort for the pet so that the teeth aren't too sharp and may scare or pierce the dog's skin, and it will help improve the hair removal functionality. The design parts that we have are the handle, which is wooden, the end caps, the receiving rail, the teeth, screws, and the rubber composite material.
Here you can see the exploded view of our pet grooming comb. The wooden handle is a shelf part. It's basically a wooden dowel. It's 2 inches in diameter. We're going to cut it down to 5 and 7/8 inch length. And you can see the plastic end caps. There's 2 of them, one on each end. They're made of plastic. They can be stamped out pretty easily. They're 2 1/4 inch in diameter, 16 inch wide. They're indented to hide the screws. The receiving rail is metal. It's bar stock, 5 and 7/8 inches in length. It's half an inch by half an inch, and the end rails are 1 1/4 inch, the screw holes for the placement. There's 47 teeth in this comb. They're made of metal. Again, they're a shelf part. You can buy that stock straight off the shelf. Cut it down to 3.5 inches in length, and they're 1/16 inch diameter. There's 2 rivets on each side, the 2 screws. They're made of metal. They're again a shelf part, 0.16 inch diameter and 0.625 in length. The rubber composite material, again, it's another shelf item. We try to keep as many shelf items as we could to keep the installation easy. They're made of synthetic rubber. They're to coat the ends. They're shelf material, and they're dipped after the comb is assembled.
Hello everyone, this is Mohammed. I will go over the DFA analysis of our project. Design for assembly is a resourceful technique used in the analysis of components and sub-assemblies to optimize the steps of assembly process, determining relevance of each part and approximate the cost of assembly. The main goal of design for assembly is to simplify the product's design and the assembly to reduce total cost. Other benefits of DFA analysis are finding ways to improve a product's quality, thus making it more reliable and often a reduction of parts, providing features that will make parts easier to grasp, move, orient, and insert will make the assembly process easier and less time consuming, resulting in lower cost. By analyzing both individual parts and whole assembly of a product, one can often find ways to improve the products. There are a few points to consider when performing an analysis. For example, try to avoid unnecessary part features, minimizing hard to pick up parts, avoid parts that are easily damaged, shaped edge, sticky or slippery, or those that can cause worker fatigue. Design for automated production, design for efficient joining and fastening, reduce a part variety by standardizing and using common parts. These are very important. By performing a DF analysis, we were able to improve our pet grooming comb, creating a better product. Here are the areas of improvement. We made improvement on handle, receiving rails, screws, and rubber composite materials, which made this, which create a better product. With these areas of improvement, we have created a higher quality product that is much more likely to last after many years of use. We created a manufacturing plan for the wooden handle used in our design to be created using the CNC milling process. Here, as you can see on the table, what we had on the original design and what we have modified by using the design for assembly method. I'm at the end of the presentation. I hope everyone like our presentation. Thank you for watching.